Logo of U.S. Department of the Interior, U.S. Fish and Wildlife Service, and citsci.org. Title on screen is Managing and Implementing Your Citizen Science Project. Module 7. Video of a small deer in the woods sniffing at the ground.
You've created a plan for your restoration project.
Image of a clipboard with the title Restoration Plan for Woodland Site. There are images of a leaf, 2 birds, a salamander, tree, and a fox. Next is a video of 2 people sitting and talking. Then an image of a girl bending down picking up an object from the ground with one hand and a paintbrush in the other.
You've talked with your partners, figured out what data collection protocols to use, and established your data management plan. Now it's time to map out how your team is going to accomplish the work.
A graphic with lots of words in different shapes and rainbow colored in the shape of a cloud with the word data management in the center. There is a hand with a pen that is pointing to the word data. Next is a video of 2 people putting sticky notes on a glass wall.
A roles and responsibility matrix can help prevent confusion about who is responsible for various project tasks. These types of matrices are used routinely by professional project managers.
Image of a pad of paper with dominoes and wooden gear wheels around it. There are 2 wooden people game pieces on the paper and text that says roles and responsibilities. Next is a graphic of 2 people moving colored letters RACI around a table diagram. The title Roles and Responsibilities matrix is above the diagram.
You can use one to keep your project on track. After watching this video, you will be able to draft a roles and responsibilities matrix for a restoration project. Identify common monitoring cadences that work well for restoration-based citizen science projects. Describe the roles of a project manager for your restoration-based citizen science project, and know where to find additional information that builds on this video series.
Graphic of 4 people holding up letters that spell out RACI in front of a table diagram.
A roles and responsibilities matrix is a chart that maps out all the key responsibilities for a project by role. Usually, the matrix will list key responsibilities down the left column and key individuals by name or by role across the top.
Table has tasks on the left ordered in numbers 1 through 4, and across the top is roles listed with letters O through E in each field. There are different shades of blue and letters RACIQ in the cells that match the same color. Then there are 5 images of men and women of various ages that are all smiling.
In the boxes, your team will determine who is responsible for, who is accountable for, who needs to be consulted on, who needs to be informed about, and sometimes who needs to be a quality reviewer for various tasks of your project. The first letter of each role, R, A, C, I, and Q, are used to depict each role in the matrix. Pause the video and take a moment to create a draft roles and responsibilities matrix for your project.
Video of a woman at a desk writing in a notebook and thinking. Next is a video close-up of a man writing on a clipboard.
You can do this with a pencil and paper or your favorite spreadsheet software. You may choose to leave the matrix blank and fill it out completely with your team later. Or you can begin filling in roles and responsibilities that have already been assigned and then complete the rest in consultation with your team.
Video of an Excel sheet with the title Roles and Responsibilities matrix example. In the first row, there are names across the top. In the second line, the mouse cursor types in the following text. Task 1. Set up meeting with the team.
Once your draft is ready, gather your team of collaborators to talk it over. Some roles and responsibilities will be obvious to everyone. Others will not. Discussing the matrix as a team will help identify less obvious roles, clarify who should have responsibility for them, and identify gaps where additional help may be needed.
Video of 8 people, some of them with laptop computers, sitting in a conference room talking with each other. Next is a video of 5 people with papers in front of them on the table, and they are having a conversation. Then an image of 4 people conversing while sitting at a table with plates and drinks.
There may not be an obvious answer for every role at the end of this first meeting. That's okay. Let your team take time to think about the roles.
Image of a corkboard with sticky notes that say who, where, what, when, how, why, and a question mark. Next is an image of a man sitting at a table with his hand on his chin, depicting he is thinking. Then an image of a woman on a cell phone.
Set up a follow-up meeting to revisit any undecided responsibilities. Let's look at an example from an actual restoration and citizen science monitoring project. Here you can see the tasks involved in this project listed on the left, including developing bird monitoring protocols, approving privacy policies, and hosting an initial kickoff meeting with partners. The names of people involved in the project are listed across the top, in some cases with their titles or affiliations. Including affiliations is useful for identifying who is accountable when staffing changes occur or project objectives shift. In each cell of the matrix, roles have been assigned so everyone knows who is responsible, accountable, or needs to be consulted or informed for each task.
A spreadsheet is shown with a list of project tasks in the far left column. Across the top of the table are the same names shown earlier. Under each of the names, a new rel has been added to include titles and affiliations, and they include restoration ecologist, deputy director, project lead, financial officer, nonprofit partner, restoration consultant, site number 2 project lead, university consultant, and engagement coordinator. Under each name, there is the letter RAC, or I, associated with each task, so that each person has been assigned a role for each task.
In rare cases, a cell may be empty if a person has no role for a particular task. Once the roles and responsibilities are laid out, it's time to think about how long different tasks may take.
Text on screen is determined project timeline. There is a graphic of a clock and a calendar on the right side of the screen. Next is an image of a colored timeline with dates and a pen pointing to the word completed.
Although your project will have its own timeline, knowing some commonalities may help during your planning. If feasible, try to plan to capture pre- and post-restoration data for the biological and physical components of the site.
Title on the screen is before. Image in the foreground of a river with a severely eroded, steep bank and mountains with snow in the distance. Image title is Big Bend of the Jordan River, Utah. Credit is John Eisenhart, DOI. Next, the title is after and the image shows the same river, now with shallow incline banks, a restored riverbank that is vegetated with green grass and newly planted trees, and stairs made of large rocks leading to the river. Image title is Big Bend of the Jordan River, Utah. Credit is John Eisenhart, DOI.
Birds, plants, water quality, and macroinvertebrate communities all have different requirements for monitoring to be considered.
Image of a river in the winter with trees and dormant, yellowish-brown tall grasses. Image title restoration site, East Helena, Montana. Credit is Brian Balmer, USFWS. Next is a video of a mountain stream with boulders along the forested stream bank.
Many restoration projects include some aspect of monitoring for birds, plants, and water. Consider how many seasons within a year and between years of data you will need to make the monitoring data useful for the project.
Video of a gray, tan, and white bird with black eye stripe, a nuthatch, sitting on a branch in the snow, and it grabs a seed with its beak. Next is wild flowers blowing in the breeze.
For example, for birds and plants, you'll need to plan appropriate times of year to capture meaningful data about the communities. It may take 2, 3, or more annual sampling efforts of plant data after a restoration is completed to capture data on annuals, biennials, and perennials.
Video of a man hiking up a hill in the woods, and then he stops to put his hands on his hips and look around. Next is a video of 2 baby birds in a nest with their mouths open in the air. Next is a close-up of plants emerging from the dirt and growing in a time lapse.
Bird communities may initially be disrupted by restoration work, but slowly return to the site over a few seasons. The takeaway is that most meaningful monitoring projects for restoration sites aren't going to happen over the course of 1 or even 2 years.
Video close-up of the back of two people's feet as they walk in boots on a path. Next is a video of a man digging up dirt and putting it in a bag as a woman writes on a clipboard.
On the other hand, there may also be a point at which continued monitoring wouldn't add enough value to a project to justify cost. For example, monitoring soil conditions at the site once every 2 to 3 years, but only for a 10-year time frame, may be sufficient.
Video close-up of two hands wearing gloves holding a pile of mud mixed with leaves, and there is a mesh bag in water below. Next is an image of a woman kneeling beside a forested stream and looking at a plant through a magnifying glass.
Each site will be unique, and you can get a sense for what is appropriate for your site by talking with science experts on your team.
Video of a man in the woods looking through binoculars up towards the sky. Next is a video of two men sitting at a desk, and a woman is standing and talking to one of the men while pointing towards the desk with her pen. Then an image of three people sitting and talking while pointing at a piece of paper.
Finally, assign someone to be the project manager for the monitoring effort, preferably someone who isn't wearing too many other hats. The project manager can be responsible for convening partner meetings, tracking the progress of different parts of the monitoring project, negotiating challenges, and, most importantly, ensuring your project gets done as close to on time and within budget as possible.
Video of a woman talking to others in the room while standing next to a large noteboard that has sticky notes. Next is a video of two people standing and talking while looking at sticky notes on a glass wall. Then an image of notepads, a calculator, stacks of coins, and a sand hourglass clock.
With a project manager, each partner can focus on their roles, while the project manager makes sure it all works together.
Image of a woman holding a pencil while leaning and looking closely at a whiteboard filled with sticky notes. Next is an image of people planting trees. Then a video of people putting together a wooden puzzle.
In the next video, we'll focus on how to bring your project to a successful close and share the project's story in a meaningful way.
Video from an aerial view of green coastal grasses and a small water inlet leading to a small estuary bay of water. Next is a video of a wolf walking through the snow and then stops to put his head in the snow, in a manner suggesting it is searching for food beneath the snow.
For more information about this video series, visit doi.gov/restoration.
Video of a bird flying in the sky. Video credit Sarah Newman, SITSI. Title on screen, thanks for watching. Text on screen is narration John Eisenhart, DOI. Production Sarah Newman, SITSI at Colorado State University. Special thanks to Chris Klein, USFWS, Brian Balmer, USFWS, Daniel Mock, State of Minnesota, Jacob Martin, USFWS, Matt Struckhoff, USGES, Tim Holzel, DOI, Sherry Skipper, USFWS, and all the partners of the Big Bend of the Jordan River Science Coordination Team. Logo of U.S. Department of the Interior, U.S. Fish and Wildlife Service, and sitsi.org.